All right, we're going to talk about systems of equations with nonlinear equations. So um, there are equations that represent like shapes or graphs or curves that are not lines. And of course, we also have lines. And so it's important that we are able to solve those systems too. And one thing that can be useful in preparation for solving those types of systems is to identify what kind of curve we're dealing with in each case and kind of imagining in our heads what are the possible ways or how many possible solutions should we expect from one of these equations, because oftentimes, and you'll see this in a minute, we get multiple solutions, and this is not always, but sometimes we do. So for example, I've got like this. If we look over here, there's a hyperbola and a line, and they have two intersection points. We can have, here's a situation where there's a parabola and a hyperbola has two intersection points, but you could just as easily have seen a hyperbola and a parabola that had four intersection points. Like what if it did something like that? There'd be four intersection points. And then again, like sometimes you have three, right? You have like that one, and that one, if with this ellipse and this circle. But if that ellipse was shifted down a little bit, there could have been four. If the ellipse was just shifted up a little bit, there would only be two. And it's also possible for there to be single intersection lines. It's possible for example, there to be like a line on a hyperbola that runs parallel to maybe the oblique asymptote, the slant asymptote of the hyperbola, where we don't have one intersection point. And so let's look at some problems. Nothing we're going to do mathematically here is going to blow your mind or anything, but it's important to be able to like identify that those same skills of substitution and elimination can algebraically anyway solve these kind of nonlinear systems as well. Right, so this one here should jump out at you right away what you should do, since everything here is solved for y already. This lends itself quite well to substitution. So what we can say is that if y is equal to x squared, that means x squared is equal to x squared minus 4x plus 4. Okay, then if you subtract x squared from both sides, you get that 0 is equal to negative 4x plus 4. Move the 4x over, add 4x to both sides, you get this. So x equals 1. And at that point now, it's just a matter of plugging in the x value into either of the two original equations to get the y value. And since we have an obvious, easy one to plug in here, if y is equal to x squared, then y is equal to 1 squared, which is just 1. So the point, what I'm saying here then, what we're saying here from this is that the point 1, 1 is on the graph of both of these equations. It's an intersection point. In fact, yeah, it makes sense because we've got two parabolas there. One of them, if I change this into a more familiar form, maybe x minus 2 quantity squared, it's the same equation. Well, it's not the same equation, it's different, but it's the same value. You can see that that bottom one is just a parabola. And standard parabola has been shifted to the right. So it makes sense that these parabolas will intersect once. Here's another one, and this one's a little more difficult. So we've got a situation here where we've got squared things and non-squared things. So this is equation of a circle. So let's sketch out what this might look like. Circle, and then the other one's a line. So we could end up with no solutions. We could end up with two solutions, or we could end up with one solution. Right? So there's three possibilities here. So unfortunately that doesn't really help us, but it does give us some kind of idea what we're dealing with here. And this problem is not necessarily super easy. I don't even know how I'm going to solve this right now, but I'm going to choose a way and we'll see if it works. So what I'm going to do is I'm going to solve this bottom equation for y. So I'm going to say y is equal to, and I'd have 13 minus 2x all over 2. Okay, all over 3, sorry. And I'll do this a little bit better, and I'll say that this is y is equal to 13 thirds minus 2x over 3. Okay, so that's what y is, and then if I plug this y in for this y here, ooh, I don't know, this is probably a bad idea, but let's just do it. So x squared plus, and now I'm plugging in this y, and I'm going to square it, 13 thirds, oh man, this is going to be bad, but it's okay, we can do it, squared equals 13. Okay, so the x squared is just x squared. Now, this is a perfect, so if we have a perfect square trinomial here, it's like if we have this, a minus b quantity squared, that like expands to be a squared minus 2ab plus b squared. So I'm going to follow that format. So the first thing would be 13 times 13 is 169. Nice. 169 thirds. Nope, 169 ninths. Sorry. 3 times 3 is 9. And then 2 times, so 2 times the first term times the second term, which will be negative 26 times 2, 52 over 9x, right? And then the last term squared, so that's just going to be plus 4x squared over 9, and that's going to equal 13. Now to get rid of these fractions, I'm going to multiply everything by 9, and so we'll have 9x squared plus 169 minus 52x plus 4x squared equals 13. This looks like it's going to be a quadratic, not necessarily a nice one. Oh, sorry, I didn't multiply the 13 by 9, so 13 times 9 is 117. Okay, so now I want to put everything on the left side and combine like terms. I'm going to end up with 13x squared minus 52x and then plus 52. That equals 0. And look, all of these terms are actually, they're factors of 13. So if I take 13 out of everything, x squared minus 4x plus 4 equals 0. Oh, okay, so this is 13 times x minus 2 quantity squared equals 0. In other words, 13 times x minus 2 times x minus 2 equals 0. So x is equal to 2, and it's equal to 2 twice. In fact, like this would make sense. So this is a parabola, right? And it looks like it has a multiplicity of 2, a 0 with a multiplicity of 2. So anyway, we take this 2 for x and we plug it back in. We say, let's plug it back in the bottom or the top equation, sure. So we have 2 squared equal, let's not plug it into the top equation, that's not smart. Let's plug it into the bottom equation. So 2 times 2 plus 3y equals 13. So 3y equals, move the 4 over. Now y is 3. Great. So these two equations, this circle and this line, intersect at only one point, 2, 3. And so that means it was this situation, right? And so we had the answer of 2, 3. Nothing crazy, nothing crazy math-wise, just ugly fractions, but it's really just polynomial multiplication and then factoring. This one here looks pretty straightforward. If y equals -1, I'm just going to plug y in everything that says y in the bottom equation. So -9 times -1 quantity squared minus 8x minus 18 times -1 minus 41 equals 0. So we're going to end up with, let's just clean this up, 4x squared, and then that's going to be -9, and then minus 8x, and then -18 times -1 is positive 18, and then negative 41, that equals 0. So we're going to add, we got 4x squared minus 8x, and then we're just going to add the -9 to 18 and the negative 41. So -9 plus 18 is positive 9, and then we've got negative 41. So we end up with negative 32 equals 0. You can do the same thing here, factor out of 4 from everything. X squared minus 2x minus 8. And then this factors to x minus 4x plus 2. So 4 equals, so then x could be either 4 or -2. Okay. And so we know actually what y is. Y is actually given to us. So what this tells me is that there are two solutions to this. And this makes sense. This is actually the equation of a hyperbola. And since the y term is negative, it's a left and right kind of hyperbola. So sort of coordinate plane situation, then the bottom equation is going to look like that, something like that. It's not a good sketch at all. But then y equals -1, so y equals -1. So we have two answers. We should have two answers to this, and we do. The two answers are going to be if x is 4, y is -1, and if x is -2, yeah, x is -2, y is also -1. And so those are the two answers to this one. All right, here's another one. This one's actually super simple. If we just add these two equations right off the bat, we're going to end up by we're going to add these. So we'll have 3x squared. The y squareds cancel out, and we're left with 15. Then x squared equals 5. So x, and this is very important, if you square root both sides, x is equal to plus or minus the square root of 5. It's absolutely not just positive 5, right? If you had if you want to say the square root of x squared, right, this is equal to the absolute value of x. And so what you would say, like if you were in the process of solving something, if you had x squared is equal to anything here, you would say square root both sides. You say the absolute value of x is equal to the square root of 3. And what we know about that is that x can then equal either the square root of 3 or the opposite of square root of 3. Square root of 3 or the opposite. So you have to do that step. It's pretty important. And so now we have two possible answers here for x, and so we're going to plug both of those in to see, we got to plug it in to see what comes out for y. So let's plug it in the bottom one. Looks like it'll be easier. In fact, let's solve the bottom equation for y first. So we've got y squared is going to equal x squared minus 4. And so if we plug in positive square root of 5, like y squared is equal to, let's do positive square root of 5 squared minus 4, y squared is equal to 1. So y would equal, by the same reasoning, plus or minus square root of 1, which is just 1. Okay, we could also plug in negative square root of 5, but you see if we did that, we'd have the same exact answer out. And so what we get, and what this means is that if x, we have 4 answers to this, and this makes sense. This is an ellipse, and this is a hyperbola. So we could have, a situation we might have here, is there's a hyperbola, and then an ellipse, like right on top of that hyperbola. So we've got 4 answers of some. I didn't sketch that very well at all, but we're going to end up with 4 answers. And so the 4 answers are going to be, we have if x is positive square root of 5, y could be 1. Here we have that answer. We have if x could be positive square root of 5, y could be negative 1. And we have if x is negative square root of 5, y would be 1. And if x is negative square root of 5, y could also be negative 1. So we have all 4 of those possible answers. Oh, here's an interesting one here. So this was using logarithms, and y equals both of these things. So again, substitution looks like the way to go here. So if we put negative log base 4 of x equals log base 4 of x minus 12 minus 3. Now if we just move everything to one side, we'd have 0 is equal to log base 4 of x minus 12 plus log base 4 of x, and then minus 3. Now by logarithm properties, I can combine these two logarithms because these bases are the same. So logarithm properties tell me that this is the same thing as log base 4 of x times x minus 12 minus 3. Oh, and then let's just move the 3 over to make it so it would be 3 is equal to log base 4 of, and let's multiply this out, x squared minus 12x. The loop trick, the logarithm loop trick, which if you don't know what that is, you should absolutely look at my video about logarithms, one of my videos about logarithms, to figure out what that is. So this is 4 cubed is going to equal x squared minus 12x, or in other words, 0 is equal to x squared minus 12x minus 64. And so this factors to x, what does this factor to? X minus 16, yeah, x minus 16 and x plus 2. Okay, so, oh no, x plus 4, sorry. X minus 16 and x plus 4. So that means that x could equal either 16 or negative 4, but it can't equal negative 4 because we cannot have a negative argument to a logarithm. There's no way to raise 4 to any power to get to be negative 4. You can get 1/4, but not negative 4. So it's not negative 4. And in that case, if y is equal to negative log base 4 of 16, because we said x is 16, well, log base 4 of 16 is 2. So y is equal to 4 to what power gives you 16? 2, so negative 2. So the answer to this then is that it's at 16 negative 2. That was not an easy problem. You have to know logarithms to do it, or you could have just graphed it, and you would find that there is only one intersection point on those graphs. So all of these skills, they transfer across all the different system of equations problems. That is not to say that there's not an easier way to do them. Absolutely there are. If you have 2 variable systems, you should totally, if you have the opportunity, if you have the ability to do so quickly, you should graph them. and find their intersection point. That is by far the best way to do it and the fastest. However, if you have a 3-variable system, there are not many graphing utilities out there that'll let you do 3-variable systems. And so there's a shortcut way for doing that. But before we get into it, that'll be in another video. But I wanted to show you one problem here as a challenge problem. And this problem, similar variations of this problem come up quite often in like not standardized tests, but like kind of competition math tests. And it gives you something like x plus y is equal to 4, and xy is equal to 3. And like this seems right away, this seems something's fishy about this. And it totally is. And then it goes a step further and says, if that's the case, what is x cubed plus y cubed? Now this is a totally solvable systems of equation problems and I love this problem. And there's even more difficult variations of the same problem. But all it comes down to is just manipulating things mathematically correctly, like follow the rules. And you can solve it. So I'd like to challenge you for this problem. If you want to, I don't know, get some kudos from me, write the answer to this problem in the comments of this video. So just write the number. So your comment should just be some number. And I'll give you a hint, it's a positive integer. So thank you for watching this video, and definitely check out future videos I have about systems of equations with more than one variable, with 3 variables plus, and how you might go about solving those simply.